I'm Shomo Data, and this is Built to Trust. Today we are turning Runbooks into something you can count on at 3 in the morning. Not shelfware, not a wiki novel, not a flowchart that nobody touches when the room spins. A runbook that actually runs is a short, ordered set of steps with proof of success, clear guardrails, and an easy rollback. It has an owner, it is rehearsed, it is time-stamped. It lives where work happens. When you build runbooks this way, recovery is faster, launches are calmer, and new teammates become effective without heroics. This episode is for teams that ship in the physical world. Hardware, software, controls, robotics, integration labs, and production lines. We will build one shape that fits all of those. We will start by defining a runbook and what it is not. We will write a one-page header that answers every question a tired human would ask. We will design steps that carry their own proof. We will rehearse at 3 in the afternoon, so it works at 3 in the morning. We will write rollback first, so you never get stuck. Then we will go domain by domain with concrete examples. Hardware bring up, software release, controls and robotics operations, integration scenarios in a HIL lab, station work on a manufacturing line. We will set freshness and coverage goals. We will tier runbooks by risk. We will connect runbooks to systems engineering and program management so evidence shows up in the same place as decisions. We will embed just culture and stop the line language. We will make your runbooks easy to find. We will kill the common failure modes and replace them with a small set of templates you can paste into Monday. Let's begin with clarity. What is a runbook? A runbook is the smallest useful set of steps to achieve a specific, repeatable result with a clear definition of done and a tested way to back out if needed. It is not a policy. It is not a novel. It is not a place to show how much you know. It is a tool you can hand to a capable teammate on a bad day and expect a good outcome. Here is what a runbook is not. It is not tribal lore that lives in one person's head. It is not a slide deck with 6-point font. It is not a document with 100 links that send the operator on a scavenger hunt. It is not a maze of conditionals that forces people to pause and guess. A real runbook is a single-page header and a table of steps. The steps are short sentences. Each step shows the action, the expected result, and the evidence to capture. There are bolded guard steps where 2 people must confirm. There are timers and explicit waits. There is a single place where a human can observe the pass and call it done. The rollback is at the top, not the bottom. The escalation ladder is on the page, and above it all, the owner's name and the last dry run date tell you whether you can trust it today. Let's write that one-page header. Every runbook starts with the same block in the same order, so nobody hunts for the basics. Name and purpose. In one line, what this runbook achieves. For example, bring up Flight Computer Rev C on the HIL rig with Watchdog arms, or deploy ingest service V4.13 to production with rollback ready, or start line 2, station 4, with fixture B and CT cloud check C owner, one human by name, not a team, not a role, a backup name if the owner is unavailable. Last updated and last dry run. ISO dates. These 2 dates tell the truth faster than any paragraph. If last updated was yesterday and last dry run was last week, people relax. If the dates are old, the operator knows to be careful and ask for a rehearsal or a fresh pair of eyes. Prereqs and tools. Access, fixtures, credentials, parts, test data, nodes, good builds, safety gear, and any partner runbooks that must be opened. Write it like a short packing list. If people always forget a cable, list the cable. Escalation ladder, incident commander, safety, comms, with the on-call contact each week. If you do not have those hats, write the local equivalent. The operator should not need to guess who to call if a step fails. Rollback summary, a short sentence for where to jump when things wobble. For example, if 2 watchdog trips in 10 minutes, revert to build 4.12 using steps 14 through 19. Or if torque verification fails twice, Stop and call manufacturing led for disposition. This summary points to the detailed rollback steps later in the runbook. Pass and fail gates. Write done when X measured by Y observed in Z. This line is the definition of done in one sentence. Done when P 99 stays under 200 milliseconds for 30 minutes with 0 critical alerts measured in the health panels observed in the ops view, or done when pose drift stays within 2 centimeters for a 10-minute hold with loop jitter P99 under 5 milliseconds observed on the rig dashboard. The pass gate forces you to stop arguing feelings and check the numbers. Now, the structure of a step. Each step is one action plus one expectation plus one piece of evidence. Action. Turn on power channel A. Expected result. Channel reads 24 volts plus or minus 0.5 and green LED lights on control board. Evidence. Screenshot of power panel with timestamp. The operator should be able to follow a step blindfolded and still know whether they are winning. Add call and response language to guard the human parts. Operator reads the action. Verifier repeats and confirms out loud. Arming interlock. Interlock armed. Applied torque 1.6 Newton meters. Torque applied 1.6 Newton meters. It sounds silly when you are fresh. It saves you when you are tired. Guard high-risk steps with a 2-person check. Put it in bold. Dangerous step. 2-person check. Name who verifies. When you guard the steps that bite, you reduce the chance of a quiet mistake. You also set a tone. Safety is not a vibe. Safety is design and language. Add timers and waits with explicit timeouts. Wait up to 120 seconds for Q to drain below threshold. If not drained, go to rollback step 7. Do not say, wait a bit. Do not say, ensure it is stable. Put a number you can measure. The goal is to stop the ritual of staring at a panel and guessing whether it is time to move on. Anchor each step to a screen, a sensor, or a log line that proves success. Name the dashboard. Name the panel. Name the ID of the scenario. If success lives in a log, show the rejects that matches it. If success lives in a gauge, show the target band. If success lives in a noisy chart, draw a line and show how you judge good. The operator should not flip between 10 tabs to check a result. Now the 3 in the afternoon rehearsal method. We rehearsed during daylight with a fresh operator who did not write the runbook. There is no side channel coaching. If the operator pauses or asks for help, you log that stumble and fix the step on the spot. You capture before and after time to complete. You bump the last dry run time in the header. The goal is a run time inside the target and 0 ambiguous steps. The runbook lives or dies by this practice. If you never rehearse, your runbook is theater. If you rehearse and fix the rough edges, your runbook will carry you when the building shakes. Write rollback before step 1. This is not optional. Write the early abort triggers. Write the safe state. Write who decides to abort. Write the time budget to rollback. If you cannot write rollback in 2 or 3 steps for a software deploy, you are not ready to deploy. If you cannot write rollback for a line start, you are not ready to start the line. If you cannot write rollback for a rig operation, you are not ready to energize. Rollback protects your last mile. It lowers the cost of trying. It turns a scary step into a confident step. Example, rollback lines to copy. If 2 critical alerts occur in 10 minutes during the soak, stop the test, call the test conductor, and revert to build 4.12 using steps 14 to 19. If loop stability exits the band for more than 30 seconds, press stop, set mode to safe, power down channels A and B, and page safety. If station 4 rejects 2 units in a row on the same CTQ, pull the andon, halt the station, and escalate to the manufacturing lead for containment. These lines are boring. They are gold. Let's go domain by domain with runbooks that actually run. Hardware bring up. The purpose is to bring up a board, a module, or an assembly safely and predictably. The header lists the ESD protocol. the fixtures by part number, the torque, wrench, and range, the known good power settings, and the safety contacts. The steps begin with a visual inspection checklist for obvious damage, then fixture checks for alignment pins and clamps, then power channel settings with a safe order, then firmware load if applicable, then watchdog armed and sanity signals checked. Each action captures evidence: a photo of the fixture seated flush, a screenshot of the power panel with voltage and current, a log line that shows firmware revision, a chart that shows thermal rise under a short soak. CTQ checks are explicit. If any CTQ fails, the rollback path leads to safe power down, fixture release, and a disposition path that includes serial logging and a short failure note. Guard steps include 2-person checks for any action that can damage the unit under test, like applying a torque close to a limit or arming an actuator without a dummy load. Software and firmware release. The header links to the change note for this release, the freeze window, the health SLOs to watch, the canary plan, the rollback build, and the on-call contacts. Prereqs include credentials, a green check on pre-deploy checks, and test artifacts. Steps include a pre-flight checklist that confirms dashboards are open, alerts are quiet, and the canary environment is healthy. The deploy is staged. Canary first with P95 and P99 and error rate. Watch for a fixed window. If pass gates hold, expand gradually with a named batch size. If a pass gate fails, follow the rollback path with a clear target time. Evidence includes screenshots of the health panels before, during, and after, a golden log diff that shows no parse or order regressions, and a note for any warning that appeared and cleared. Guard steps include freezing partner changes during the window, and a 2-person check to confirm version numbers before production traffic is routed. Controls and robotics operations. The header names interlocks, mode switches, e-stop locations, safe positions, and watchdog expectations. It names the test conductor, the safety officer, and the data scribe. Steps start with a walk around call out, a power order, an interlock check, and a pose sanity check. The operator calls the step and the result. The verifier repeats. There is a hold before motion where a human confirms the scene is clear. Fault injection steps are scheduled when appropriate. For example, a sensor dropout or a bus flap. Evidence is the rig dashboard screenshots with timestamps, a loop jitter histogram that shows P99 under the target, and a time-based correlation check. Rollback returns to a safe mode, powers channels down in a safe order, and pages safety if a threshold is crossed. Guard steps call for 2 people before removing physical guards or entering a zone. Integration lab scenario runbooks. The header includes scenario IDs, seeds, versions, fault schedule, and the evidence pack location. The prereqs include a versioned configuration, a rig health check, and a partner runbook link. The steps include loading the scenario, starting captures, running the scenario, injecting scheduled faults, and capturing results. A pass means the scenario produced expected outputs within tolerance. A fail becomes a bug or a blocked case. The evidence pack checklist includes a canonical set of screenshots, a golden log diff, a table of pass and fail, and a short narrative that names 1 insight and 1 change. Rollback is a consistent revert to a known good config and a rig reset with a quick smoke test to confirm the rig is ready for the next team. Operations and manufacturing stations. The header names the station, the talked target, the owner and backup, the escalation ladder, the safety gates, and the CTQ checkpoints. The steps are short, each with action, expected result, and a simple evidence mark. Fixation, torque, connect, verify, tag. The system prompts for a photo or a measurement where it matters. If a CTQ fails, the andon path pulls help. The runbook includes a deviation path when a part falls outside spec, but is still usable with an approved variance. The operator should not guess whether to continue. The rule is on the page. Now, metrics that make runbooks a living system. Freshness is the percentage of runbooks updated within an appropriate window. In fast-moving development, 30 days is reasonable for Tier 1 runbooks. In stable production, 90 days may be fine for Tier 3 runbooks. Coverage is the percentage of critical flows with runbooks. If your most important recovery path has no runbook, your coverage is lying. Time to recover is the baseline time to complete a standard recovery with the runbook. The trend should move down as you rehearse and improve. Dry run cadence should be monthly for Tier 1, quarterly for Tier 2, and by change for Tier 3. Evidence completeness is the percentage of runs that include the screenshots and log links you asked for. If evidence is missing, your audits will hurt and your trust will sag. Tier runbooks by risk, so you do not burn the team with the same ceremony for everything. Tier 1 is safety and mission critical. These runbooks require 2-person checks on guard steps and monthly rehearsals. Tier 2 is high impact. These runbooks get a quarterly rehearsal and on-call verifies the header before use. Tier 3 is low risk. These runbooks are updated on change and spot checked. The tier dictates the rehearsal frequency and the depth of evidence you demand. Write this policy down, post it, use it. Connect runbooks to systems engineering. Requirements map to runbook steps and to evidence. If a requirement says P99 under 200 milliseconds for 12 hours under jitter, your verification method might be a soak runbook. The runbook step says run the soak for 12 hours with jitter profile J. The evidence is the P95 and P99 panels and the log link. When a reviewer asks whether the requirement is verified, you click the runbook, then the evidence. Interfaces are seams that deserve their own runbooks. A seam runbook proves interface contracts at the boundary with golden logs. It runs a limited soak at seam conditions. It records evidence. It names the current version of the interface control document. If the seam changes, you rehearse this runbook before you declare the seam safe. Connect runbooks to program management. A key landing is not ready until the runbooks on the path are ready. Program management can set a runbook readiness gate. For example, runbook header complete, last dry run within 30 days, escalation ladder present, rollback tested. Program management ties runbook freshness to the plan. If a demo or a flight or a ramp depends on a procedure, the runbook is part of the definition of ready. The weekly roll-up should include runbook status where it matters. You can put freshness, coverage, and time to recover on the dashboard. For production, you can add first pass yield and CTQ CPK and link station runbooks. For development, you can add scenario coverage and link scenario runbooks. When PMS use these signals, they stop asking for theater and start asking for readiness. Embed safety and just culture inside runbooks. Use stop the line language in the header. Write the sentence. I might be wrong, and I do not want to be quiet and be wrong. I am stopping for safety. Give the operator that exact phrase. Make it the norm. Include severity tiers for incidents and name the hats for an S1 or S0. The runbook can say, if the trigger fires, page the on-call and name the incident commander, safety, and comms roles. Include a small notes field at the bottom that says what differed from expectation. This is not a place to blame. It is a place to capture reality for the next improvement. If a step was confusing, write it. If the panel looked different, write it. The owner reads these notes every week and updates the step table. Make runbooks easy to find. Use short URLs and QR codes at the rig and the station. Print the header and tape it where hands go. Version runbooks in your code or docs repo. Put nearest neighbor links at the bottom of each runbook. Preparation, execution, verify rollback. If you are in a rush, the links are the map. Tag runbooks by system, scenario, and severity, so search works. If an alert fires, the alert should link to the runbook to open. If a dashboard panel turns red, the panel should link to the runbook to run. Do not make a human look in 5 places. Let's kill some anti-patterns and replace them. wall of text runbooks die today. Replace them with step tables and screenshots and short sentences. Outdated steps die today. Add a freshness gate on pull requests, releases, and drawing changes. If a change touches a runbook, the runbook must be updated or a ticket must be created before you merge. Single person dependency dies today. Rehearse with a new operator and mandate a backup owner. Hidden runbooks die today. Link from dashboards and alerts. Print headers at point of use. No rollback dies today. Add early abort triggers and timed exits. Do not say try for a bit longer. Say what happens and when. Another anti-pattern is false precision in steps. If an operator has to type a command with 10 flags from memory, the runbook is hostile. Put the exact command on the page. Another anti-pattern is an unlabeled safety step. Guard steps need bold labels in call and response. If a step can change the state of a system in a dangerous way, mark it so nobody can miss it. Here is your action kit. We will write the templates you can paste into your tools right now. Runbook header template. Name and purpose, owner and backup, last updated, ISO date, last dry run, ISO date, prereqs and tools, escalation ladder, IC, safety, communications on call contacts, rollback summary, pass and fail gates, done when X, measured by Y, observed in Z, step table template, step number, action, expected result, evidence to capture, guard yes or no, timer or wait, rollback path if this fails, rehearsal log snippet, who ran it, when, time to complete, stumbles or changes made, next review date, rollback paragraph snippet, triggers that cause rollback, decider who calls it, timeline target to rollback, steps to reach safe state, notification and logging, metrics dashboard starter, freshness percentage, coverage percentage, time to recover trend, evidence completeness rate, last dry run age distribution, tier distribution for your runbook set, tiering policy 1-pager, tier 1, safety and mission critical, 2-person checks, monthly rehearsal, evidence pack, required, tier 2, high impact, quarterly rehearsal, evidence for pass gates, tier 3, low risk, update on change, spot checks allowed, print label with QR, runbook name, owner and backup, short URL, last dry run date. Now a few short stories where these shapes changed outcomes. In a HIL lab, teams shared a rig that looked stable until late at night. Runs failed in ways that were hard to reproduce. The runbooks were long and vague. We built short header plus step table runbooks with scenario IDs and seeds and a fault schedule. We rehearsed at 3 in the afternoon with new operators. We added a time-based correlation check to the steps. The evidence packs started to look the same. When a run failed, the data told us where. Time to recover fell. Teams trusted each other because the steps were not a mystery. On a software platform, deploys worked when the best engineer was awake. They failed in odd ways when others tried. We wrote a new runbook with rollback first. We put the go and no-go paragraph at the top of the header. We staged canaries with fixed windows. We demanded screenshots of the same panels every time. We rehearsed in daylight. The first deploy with the new runbook was boring. The second was boring. The team started sleeping. That was the goal. On a line, Station 4 had a failure that showed up in scrap on Fridays. The runbook was on paper, out of date, and the guard steps were not bold. We wrote a new one with CTQ checks and torque verifications and a photo step. We printed the header with a QR to the latest version and taped it at the station. We added an and-on rule to halt after 2 CTQ fails in a row. First pass yield went up by 2 points in a week, then 2 more. The station stopped being a Friday surprise. In a robotics test, a team had a perfect sim and a rough field. The runbook did not include a post-sanity check or a watchdog expectation. We added both with explicit pass gates and a hold before motion. We added a sensor dropout fault injection step. We rehearsed with a person who did not write it. A week later, the field run was calm. When a dropout happened, the system degraded gracefully and the operator called the step and the result. Nobody panicked. The test conductor smiled and wrote the evidence link. Now, remote and hybrid nuances. You can run rehearsal and production on distributed teams if you write and capture evidence. Set an asynchronous rule. Runbook updates post by 9 in the morning local. Rehearsal logs include screen captures or rig photos. The data scribe posts screenshots as the run proceeds. Questions live in a single thread per run with timestamps. If a decision is needed, the help card format is used. Who decides by when? Options. Impact. Link to the decision log entry. For follow the sun work, assign a baton owner who owns the runbook state at each handoff. When the baton passes, the new owner posts one sentence. I have the baton. The next step is X. The runbook link is Y. You do not need a meeting for every handoff. You need clarity. Let's close with a simple weekly habit that keeps runbooks alive. Every Friday, owners skim the notes at the bottom of their runbooks and make one improvement. Tighten one sentence. Add one screenshot. Bold one guard step. Update the last dry run date if you rehearsed. If nothing changed all month, schedule a dry run. In the Monday intent, managers add one line. Runbook readiness for the week's landings. Yes or no? If no, name what you will do today. It is not glamorous. It is reliable. A runbook that actually runs looks boring on paper. It is thrilling when the stakes are high and the steps just work. It frees your best engineers from being the only person who can push the button. It lets new teammates contribute without fear. It turns audits into printouts. It makes your integration labs safer and your station steadier. Most of all, it turns recovery into a routine. When the room shakes, you want a routine. If this episode helped, follow Built to Trust wherever you listen. Hit subscribe. Share it with a teammate who has ever stared at a blinking cursor and wished for one clear page with the right steps. Your ratings and reviews help more builders find the show and build with more truth and less drama. Next week is episode 12. Grow the Humans. We will talk about ladders, one-on-ones, feedback, and fair promotions. We will write a simple ladder that focuses on outcomes and trust, a one-on-one rhythm that surfaces truth, and a feedback habit that moves performance without theater. We will keep the same tone, clear words, small tools, Monday ready. I'm Shomo Data. Thanks for listening.